Hello friends, welcome to Susan and John MathTube. In this video, we will go through the past paper questions in power series method. Okay, this is one question I saw which kept on repeating many times. Y double dash plus x y dash plus y equal to 0. So I hope you remember the method. What we do is we assume the power series a0 plus a1x plus a2x squared to be the required solution. We pretend as if we know the answer. Anyway, in series notation, it becomes m equal to 0 to infinity amx power m, and when you differentiate, the most important thing, a0 will become 0, so the sigma starts from m equal to 1, and the second derivative sigma starts from m equal to 2, and the other part is just like our differentiation formula. Now what we do is we plug in all these stuff into the given equation, because a solution will balance the equation. You should always remember, a solution will balance the equation. So eventually we will get something like this. Y double dash means this sigma m equal to 2 to infinity am m minus 1 x power m minus 2 x multiplied by this, etc, etc. Now why I colored this x in red is because before taking the coefficient of x to the power k, or when you find the general term, this x should be taken inside. So this is very important. So in the next step, what you do is you take this x inside so that the power becomes whole power m. I'll repeat once more. This x should be taken. Whatever quantity is outside the summation must be taken inside the summation. And remember the rule, a power m times a power n is a power m plus n. So we have x times x power m minus 1 giving us x to the power 1 plus m minus 1, which will be m. Okay, now the most important step in the procedure, equating coefficients of x to the power. You can use anything. I'm going to use the letter k. I might have used other letters in the previous videos, but let's use the letter k. So do you remember the trick? You look at summation 1. Okay, I'll color it in blue. And you look at summation 2. I'll color it in green. And the third one, I'll color yellow. So the power of x in the first summation is m minus 2. I want m minus 2 to become k. That means I should use the value m is equal to k plus 2. So I'm going to replace m with k plus 2 in the first summation. So I get the term. Remember, this contains infinite number of terms, and only one term will have power k, and that term can be found very easily using the trick. The required power is equal to k, which gives us m is equal to k plus 2. So all you have to do is you have to replace m with k plus 2. So we get a k plus 2, k plus 2 times k plus 2 minus 1 is k plus 1. Now look at the green summation. In the green summation, the power of x is m. So I want the power to become k. That means m should be k. So that will give me a k times k plus. Now the last one, same thing. The power is m should be k. So we get plus a k is equal to 0. Now do you remember what to do next? We have to write the bigger suffix in terms of the smaller one. The bigger one is a k plus 2, of course, and I can see something common here. So a k plus 2 times k plus 1 k plus 2, a k will come common, so we end up with a k plus 2 is equal to minus k plus 1 a k, the whole divided by k plus 1 times k plus 2. So this k plus 1 will get cancelled. So we get ak plus 2 is equal to minus ak by k plus 2. Now things are like what you call really easy. Now remember, the differential equation is of order 2. So we will write every coefficient in terms of a0 and a1. Remember, the answer will have a0 and a1. So every coefficient will be written in terms of a0 and a1. Okay, so let's start. Okay, this is the easiest method. You put k equal to 0. When you put k equal to 0, what will you get? a0 plus 2, that gives me a2 is equal to minus a0 by 2. Got it? So we got the first value. Now I'll put k is equal to 1. When you put k equal to 1, what will happen? 1 plus 2 is 3 and a1, 1 plus 2 is 3. So we get a3 is equal to minus a1 divided by 3. Okay, now let's put k is equal to 2. When you put k equal to 2, we'll get a4, and a4 will be how much? a2. We are putting k equal to 2. a2 by 4 minus a2 by 4. Now you know what to do. We have to replace this a2, right? So we get a4 is equal to minus will be plus. So a0 by 2 times 4. Now what we do is we put k is equal to 3. When you put k equal to 3, we get 3 plus 2, 5. a5 is equal to minus a3 by 3 plus 2, 5. Now we have to replace this a3, that is minus plus a1 by, so a5 is equal to a1 by 3 times 5. If you want, you can continue. Now I got the trick. You can do that remaining part. It will be a0 by 2 into 4 into 6. Here we will get a5 by a1 by 3 into 5 into 7, etc. etc. Now what we do is we plug in everything into equation number 1. Do you remember how we started? We started like pretending we know the solution. We were assuming let y equal to a0 plus a1 plus etc. be the solution. Okay, so what we do is by 1, the required solution is a0 plus a1x plus a2x squared plus a3x cubed plus a4x power 4 plus a5x power 5 plus etc. Now you can never find a0 and a1 because our plan is to write everything in terms of a0 and a1. Now tell me what is a2. A2, here. So that is a minus, so I'll erase this plus and make it minus a0 by 2 x squared minus a1 by 3 x cubed plus a0 by 2 times 4 x power 4 plus a1 by 3 times 5 x power 5. And if you found the next term, you will get something like this: a0 by 2 into 4 into 6 x power 6 minus a1 by 3 into 5 into 7 x power 7, etc. Anyway, in examination, there should be 3 non-zero terms along with a0 and 3 non-zero terms along with a1 if they exist. Okay, so we get 1 minus x squared by 2 plus x power 4 by 2 times 4 minus etc. plus a1 into x minus x cubed by 3 plus x power 5 by 3 times 5 minus etc. Okay, another question that I saw which was repeated is this one. And if you do not use summation method, you are going to have a very bad time with this problem. And summation method is the easiest method to solve this. Okay, another warning. Can you see what I did with this equation? You have to distribute y dash, y, etc. if you have the form a minus b. So remember, this is the given equation. Now the usual drama, let the solution be a0 plus a1x plus a2x square blah blah blah, put it into sigma, and then we will write a solution will balance the equation. By the way, don't forget, equation means the one which I have already simplified. This is something very important. Okay, and I plugged in everything. And now, do you remember in the last problem itself I told you something very important? I should not keep things outside the summation. I should not keep any quantity outside the summation. So what should I write next? We can write equating coefficients of x to the power k. So look at this. I want my, now I'm going to look at term by term. So m minus 2 should become k. So I should plug in m equal to k plus 2. Here I have to plug in m is equal to k. Here I have to plug m equal to k minus 2. And here I forgot to write x power m. So I had to put m equal to k. It was here. I just left it. Okay, so let's start. So we get a k plus 2. So that will be k plus 2, k plus 1. I'm going to write k plus 1, k plus 2, same stuff. Minus 4 into a k times k plus 4am minus 2 minus 2 ak is equal to 0. Now we should write the bigger one. Of course, the bigger one is k plus 2. The smaller ones are k and k minus 2. K and k minus 2. Yeah. So I'll get a k plus 2 is equal to, I'm going to write these two things together. So 4 k times ak plus 2 ak minus 4 ak minus 2, the whole divided by, okay, now we have come across the, what you call, difficult part, so things will be easy. But one very important thing, remember in equation 1 we told very clearly, let the solution be a0 plus a1x plus a2x squared plus etc. So basically, if you ever want to find the value of a minus 1, you have to understand such a term does not exist, and mathematically we say it is equal to 0. So suppose you want a minus 2, the value will be equal to 0. Suppose you want a minus 3, the value will be equal to 0. Okay, so let's start with our k plugins. So we start with k is equal to 0. When you plug in k equal to 0, you're going to get a2 is equal to, this will vanish, this will be the, so 2a0. Can you see a minus 2? Just now I was telling you, if you get a minus 2, a minus 1, all these stuff will be 0. So you get divided by 1, 1, 1 into 2, 2. So a2 is equal to a0. Now put k is equal to 1. So what do we get? a3 is equal to, so 4a1 plus 2a1 minus 0. So that will be 6a1 by 2 into 3. Okay, so that gives me a3 equal to a1. Now go for the next value. But remember, you have to practice a lot of problem if you want to be fluent and if you want to be confident in your exam. So put k is equal to 2. When we put k equal to 2, we get 2 plus 2 a4 is equal to 8a2 plus 2a2 minus 4a0 by 2 plus 1 3 and 2 plus 2 4. So we get a4 is equal to, what is a2? We have to replace this a2 with a0, so we end up with a0 divided by 2. And here put k is equal to 3, a5 is equal to So 4 into 3, 12. 12 A3 plus 2 A3 minus 4 A1 divided by 3 plus 1, 4. 4 into 5. So eventually A3 becomes A1. A3 becomes A1. So 12 plus 2, 14. 14 by 10. 10 by 20. That gives me A1 by 2. You can find more values, and that's it. Our usual step. What should be the next step? So our solution is A0 plus A1x plus A2x square plus A3x cube plus A4x 4 plus etc. etc. You plug in the value, you will get the answer A0 times 1 plus x square plus x power 4 by 2, and the pattern goes like this, and A1 x plus x power 3 plus x power 5 by 2 plus etc. If you want, you can find more terms, but in examination there should be minimum 3 non-zero terms. Okay, now another question. Actually, I think the question came by accident, because normally they don't expect you to solve such questions, but the question is not wrong. So that's a big problem. Normally they don't ask questions like this. So please write solve y double dash minus y is equal to x. I strongly believe this should be equal to 0, but this question is not wrong. We can because x equal to 0 is not a singular point, so we can work out this question with power series method. Anyway, let's start. So the usual stuff. What's the usual stuff? So here comes the usual stuff. Let the solution be blah blah blah. Call it equation number 1. Convert it into sigma notation, and then we plug in. So when we plug in, look at this. The equation looks kind of weird because of that x on the right hand side. So we get sigma m is equal to 2 to infinity am m minus 1 x power m minus 2 minus sigma m equal to 0 to infinity am x power m is equal to x. Now look at this. If the right side is equal to 0, things were very easy, because we can equate the coefficients so easily, because the right side coefficients will be 0. Now here what we do is, there is a trick. So what I am going to do is, if k is a number not equal to 1, 1 by the way is the power of x here, and all other powers are 0. Did you see? 0x to the power 2, 0 is the constant, plus 0x to the power 10, everything is 0. So I'm going for two different cases. If k is not equal to 1, then coefficient of x to the power k on both sides gives, okay, so the trick is the usual trick. M minus 2 must become k, so we get a k plus 2, k plus 2, k plus 2 minus 1 minus a k is equal to 0, because the coefficient of x power k other than x power 1 does not exist. So the right side coefficients are 0. Now comes the critical case. Anyway, we will make this into a reduction formula. A k plus 2 is equal to a k by k plus 1, k plus 2. Call it equation number 2 and put k not equal to 1. That means you are not allowed to plug in k is equal to 1. You can plug in any quantity other than 1. Okay, now comes our critical case. If k is equal to 1. So I want my power to become 1. Look at this. The power of x in the first summation is m minus 2. I want m minus 2 to become 1. So I should plug in m is equal to 3. So what does it give me? We get a3, 3 minus 1 minus, I want the power, I want m to be equal to 1, so that it becomes x power 1. So I get a1 is equal to, what is the coefficient of x? 1. So we end up with a3 is equal to a1 plus 1 divided by 3 into 2, 6. So look at this. Now we have the reduction formula. ak plus 2 is equal to ak by k plus 1, k plus 2, k not equal to 1. And a1 plus 1 divided by 6 if k equal to 1. If k equal to 1, this will become a3 and the value of a3 is written here. Okay, now comes the last part. So what do we do? As usual, we put k equal to 0. When we put k equal to 0, we will get a2. When you put k equal to 0, you have to use this. So that will give us a0 by 2 into 1, 2 factorial. That is very smooth. And now we can put k is equal to 1. And when we put k equal to 1, we get a3. And a3 we have already written. a1 plus 1 divided by 6. 6 is actually 3 factorial. Now k is equal to 2, we get a4 is equal to a2 by 3 into 4, and we plug in this a2 value, that gives me a0 by 4 factorial. K is equal to 3, we get a5 equal to what will we get? We have to put k equal to 3. Remember, k equal to 3 means we use the first one. Now we don't have to use this, we already used it here. So a5 is equal to a3 by 3 plus 1 is 4, 4 multiplied by 5. Now what is a3? Plug in this value, so a1 plus 1 by 5 factorial. I kind of like got the trend, so but I'll do one more thing. K is equal to 3, a6 equal to, eventually you'll get a0 by 6 factorial, and k equal to 2, 3, 4. Yeah. So we have to put 5. So a7 is equal to, eventually you'll get a1 plus 1 by 7 factorial. So we have to plug in these stuff. So let's see. So we are going to get y is equal to, I'm going to write like this, a0 plus a1x plus a2x squared plus etc. Now I'll do one thing, because the substitution looks a little bit complicated. I'm going to write a0 plus a2x squared plus a4x power 4 plus a6x power 6 plus dot 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 plus a1x plus a3x cube plus a5x power 5 plus etc. Now let's plug in the values. Y is equal to a0. What is your a2? Yeah, a0 by 2 factorial x square plus a0 by 4 factorial x power 4 plus a0 by 6 factorial x power 6 plus etc. That is very smooth. Now a1x remains as such, and here we will get a1 plus 1 by 6. 6 is 3 factorial x cube plus a1 plus 1 by 5 factorial x power 5 plus etc. If you want, you can simplify a little bit. You can create plus 1, minus 1, etc. Or you can leave it as such. Now another problem that I saw in the question paper is solve y double dash minus y is equal to 0. This will be very simple because we just solved so many complicated problems, but make sure you try it right now, because you need a lot of practice if you want confidence in the exam. So I'll wind up this video right now. So I'll be back with another video very soon. So till then, bye.